Um, Jesus Christ. Wait. No, sorry. I'm not sure. How can I? Is that a purple?
No, I saw it. I could see it.
You can see it.
I did see
Okay.
it. Yeah, it was the blue background and it looked like it was.
Okay. Is that? Can you guys see this one?
Yeah. It's just a matter of where we can hear the sound, but
Yeah. Okay. Got it. So. Yeah, so our group have 4 members here, and first one Yuhan Chen, second one Yibo Wang, and third one is me, Daming Luo, and yeah, final one is Watching Zhou.
Okay.
And yeah, this is our group presentation.
Thank you very much. Okay, so there is a problem, and it's just that you didn't share the sound. Okay.
Oh, I didn't share the sound. How?
Okay, so it's all right. I'll explain it. Everybody's done it today.
I got it. Got it.
Turn your share screen off.
Yeah. I already shared the sound. Jason, I already shared the sound. Is that?
No, but
I'm not sure. Is that?
In order to get the sound to work.
Okay, got it.
We need
Wait
to
a
do
second.
a couple of steps. Okay, so stop sharing.
Yeah. Okay. Stop sharing.
Stop sharing now. When you share screen this time, don't click on OK. In the bottom left-hand corner of the dialog box that sprang up, it has a little checkbox, Share Display Screen.
Okay, got it.
That, then pick your file or your window that you want to share.
Okay, got it.
Now we'll be able to hear you.
Okay.
No worries.
Well, we are going to talk about the Xenos.
Much better, thank you.
Our members are Yuhan Chen, Yibo Wang, Daming Luo, and Bojun Zhou. This report focuses on studying and explaining the Arclist paradox in Xenos paradox. In terms of proof, the dichotomy will be used for mathematical limit discrimination. This paper discusses the Zeno paradox. First, introduce the essence of the Zeno paradox. Then, discriminate the mathematical limits of the Zeno paradox by dichotomy. And finally, the Arclist limit analysis. Arclist paradox varies motion and stillness, exaggerates relative stillness, and denies absolute motion. This paradox reflects that space-time is not infinitely spherical, and the motion is not continuous. Arclist is a mythical figure who is good at running in ancient Greek mythology. Zeno assumes that the tortoise starts 1,000 meters in front of Arclist and races with Arclist, and assumes that Arclist is 10 times faster than the tortoise. If Arclist runs 1,000 meters, set the time as t, and the tortoise is 100 meters in front of him. When Arclist advanced 100 meters, the time it took to advance was 1/10 of t. At this time, the distance between tortoise and him was 10 meters. When Arclist advanced another 10 meters, the time it took to move forward was 1% of t. At this time, the distance between the tortoise and him was 1 meter. According to this logic, the tortoise will create infinite starting point in its progress. There is always a distance between Arclist and the tortoise, so no matter how small the distance is, Arclist will never catch up with the tortoise as long as the tortoise keeps climbing forward. Zeno said, motion is no true, and the Arclist must go through half of the space before reaching the goal. This paradox reflects that time and space are not infinitely spherical, and motion is not continuous. Zeno's explanation adopts a discrete time system. No matter how small the time interval is, the whole time axis is still composed of infinite time points. Zeno certainly knew that Arclist could catch up with tortoise, but Arclist can catch up with the tortoise in Zeno's paradox, because Zeno secretly changed his concept. In fact, due to the speed difference between Arclist and tortoise, Arclist will catch up with the tortoise after a specific time.
We can make the hypothesis. First, any movement is from one phase moving to the other place. Therefore, if it is impossible to get one place to the other, it means it is impossible to have a movement. Second, if the distance between one place to the other is infinity, it is impossible to get from one place to the other. So combine the first and second, we can find that if the distance between one place to the other is infinity, there can be no movement. And next, the distance between two places can always be separated into many infinitesimal distance. So the distance between one place to the other is infinity. So combine all the points above, we can get that the movement is impossible. That is ridiculous, but we can make the example to disprove this hypothesis. Here is an example. We start from one place to run to the other place by uniform velocity. So, first, you must run the first half of the distance, and then you must run the first half of the remaining distance, and then the first half of the remaining half, and so on. So the time you run the first half distance is t. So we can get that t plus t over 2 plus t over 4 plus t over 8 plus t over 16 and so on. And we can combine these to get the formula that s is equal to t times many things until t over 2 power of n minus 1. And we get that it is equal to 2t times 1 minus 1 over 2 power of n. When n approach infinity, the s is equal to 2t.
After the previous analysis, I'm going to introduce a detailed limit analysis of Zeno's paradox. According to the dictionary paradox mentioned above, we will use Achilles and the tortoise as the object of research. And we suppose the Achilles speed is v0 and the tortoise is v1. The tortoise moves first, and the first distance that the tortoise moves is s0. Then the Achilles starts to chase the tortoise. The chase process is showing as this figure. As this figure shows, the Achilles will start move as the tortoise simultaneously after the tortoise move. He and tortoise are located at points A and C, respectively, and the distance between the 2 points is s0. The following process is referred to above. When Achilles reaching to point C, the tortoise goes to point D, and the distance between point C and point D is s1. The distance fell from s0 to sn minus 1 based on the previous inference. We can infer that the following progress. Since the time taken by Achilles to pass through the point A and C, which is equal to the time taken by tortoise to pass through the point C and D. Therefore, we can get a formula like this one. S0 over V0 is S1 over V1. And then we can get the S1 is S0 times V0 over V0. And after that, we can get the S1 over V0 is S2 over V1. And then, in conclusion, we can get S2 is the S1 times V1 divided by V0. And that will be easy to get the S3 is V2, S2 times V1 over V0. And the Sn will be Sn minus 1 times V1 over V0. And then the sequence is going to be Sn is S0 plus S1 plus S2 plus Sn minus 1. And then all of this thing is going to be the S0 plus S0 times V1 minus V0 divided by V0. plus S0 times V1 divided by V0 power to 2, and plus S0 times V1 over V0 power to n minus 1. So due to Arclis is faster than Tortoise, we said the speed of Arclis is V0 is 10 miles per second, and the speed of Tortoise V1 is 1 mile per second. And then we can get this formula. The Sn equals S0 plus 1 over 10 times S0 plus 1 over 100 times S0 plus 1 over 100 power to n minus 1 times S0. After we evaluate this geometry sequence, we got Sn equals bracket 1 minus 1 over 10 power to n bracket times S0 divided by 1 minus 1 over 10, which equals to 10 divided by 9, and times S0 minus 10 divided by 9 times S0 times 1 over 10 power to n. And then we try to use the limit to this formula, and then what we got is limit n to the infinite. Sn equals to limit 10 divided by 9 times S0 minus limit 10 divided by 9 times S0 times 1 over 10 power to n, and which equals to 10 minus 10 divided by 9 times S0, which is larger than S0 itself. And in conclusion, according to this calculation and invariance, the Arclis will exist totals in a certain location after n times.
The purpose of the dichotomy paradox and Achille and the turtle paradox proposed by Zeno is to illustrate that movements are contradictory, and Zeno tries to prove that movement does not exist through the paradoxes mentioned above, and based on his subjectivity, Zeno denies objective existence of movement. Also, Zeno used some logical theories to demonstrate his theory. This article will use his calculation and limit to analyze Zeno's paradox mathematically, and it turns out that Zeno's point of view is wrong, and he misunderstood the argumentation relationship between relative and absolute, and confused the concept of infinite division, leading to a paradox. However, these paradoxes have a significant effect on the development of mathematical limits, and this is our reference list. Thank you guys for watching our presentation. If you have any questions, please contact us. Thank you again for watching the presentation.
All right, thanks guys. Thanks very much for that. I appreciate that.